Ladies and gentlemen, this is Mrs. Gorkiewicz. I'm going to talk to you today about Lesson 4 of Unit 4, titled Polygons. Okay, so what I would like you to do to start is copy down this definition of a polygon. Okay, a polygon is a closed figure with straight sides, and those lines also cannot cross. Okay, so a polygon is a closed figure, meaning we can't just kind of leave it open like that. Okay, what's happening there? Okay, so it has to be closed. This is a problem. It has to have straight sides, and they don't cross. Okay, so copy down that definition and come back. If you're done copying down the definition, let's just go through a few examples here. State whether each figure is a polygon. If not, explain why. So let's just start at the beginning. What do you guys think about this one here? That one is, yes, that's a polygon. It qualifies all of these rules, I guess you could say, in the definition. This one is also yes, okay? It looks a little bit more like a plus sign, but that's a polygon. This one is no. Okay, we have a problem with these curved sides here. We don't like those, or curved corners. This one is also a no. We have curved lines. This one is yes. This one is no. It's three-dimensional. We can't have anything that's three-dimensional. This one is also a big no because the lines cross. And this one is also a big no because we have curved sides. Okay, so that's just a general idea of a polygon. A polygon is kind of a fancy geometric term for a shape. That shape has to have certain qualities, and they're here in this definition. Closed, straight lines, don't cross. All right, let's keep going. Our polygons do have different special names depending on what kind of sides they have. Okay, so a three-sided polygon is a triangle. I think we all know that. A four-sided polygon is called a quadrilateral. A five-sided polygon is called a pentagon. Six-sided is a hexagon. Seven-sided is a heptagon. Eight-sided is an octagon. Nine-sided is a nonagon. And 10-sided is a decagon. Okay, there are some more words for 11 and 12-sided, but that's beyond what we need to know here in 7th grade. So please do take a moment, pause the video, and copy this table into your notes. Okay, just these, I guess there are 3, 6, 8. Those 8 here. Please do copy them down. All right, thank you. And come on back. All right, if you're finished copying down some vocabulary here, what I want to get into next is something called a regular polygon. Okay, a regular polygon is a special type of polygon, and it has all sides that are equal and all angles that are equal. Okay, so all sides have to be exactly the same, and therefore all angles have to be exactly the same. Sorry, I put that a little bit ugly there. All right, just so you can read it. Okay, all sides are equal, all angles are equal. Here in this activity, it says to tell us why they are not regular. Okay, so the first one in A, that one is not regular. I have 4 sides that are exactly the same, but the problem is the angles. That angle is clearly not the same as that one there. Okay, number B, this one is not regular. You might think it is because you have a nice right angle there, nice right angle there. You're seeing a lot of nice right angles with corners, but the problem is this piece here is actually an angle of that figure, and that's more like a 270-degree angle, so that's why this shape here is not regular. It has not equal angles, actually. Okay, part C, we have 1, 2, 3, 4 equal angles, but the sides are different. Clearly that is shorter than this piece here, so that one's not regular because of the sides. And then D is the same as C. These 1, 2, 3, 4 look to be the same, but that one there is clearly longer. Okay, so part D is also a problem with the sides. Okay, so if you haven't taken a moment to pause and write down this definition, please do. A regular polygon is simply one that has all equal sides and all equal angles. Okay, and lastly in this lesson, we're going to talk a little bit about triangles specifically. Triangles are special because they have lots of different names. We can classify a triangle based on its sides. Okay, what are happening to the actual lengths of the sides of the figure? An equilateral triangle has 3 sides that are exactly the same. Okay, all equal sides. All 3 are equal. That's called equilateral. An isosceles triangle has 2 sides that are the same. Okay, whereas this one down here is different. That's called isosceles. A scalene triangle has three different side lengths. All three are a different length. Okay, so that's based on the sides. We also give triangle a second name, kind of like you and I have a first and a last name. Every triangle has two different names. We also classify triangles based on their angles. We have an acute triangle, has all acute angles. All three of these, in this case, they all look to be different, but all three of them are less than 90 degrees. All three are acute. We have a right triangle in which one of the angles is 90 degrees. We have an obtuse triangle in which one of the angles is obtuse. Okay, so feel free to pause the video right now, write down all of those words there, all these different vocabulary terms for triangles, and then come back. All right, if you're back, if you've written this down in your notebook, I want to take you to our activity today. Our activity today is this sheet here. Okay, what I want you to do is come up with all the different types of triangles based on their two names. So for example, maybe you have a scalene acute. A scalene acute. So one name and a second name. What I want you to do is draw that triangle in GeoGebra and then make a sketch on the sheet. Okay, so draw it in GeoGebra first because GeoGebra allows us to move things around. I'll show you what that looks like in a second, and then draw it on here. So if we have three different triangles based on their sides, what I want to think about you guys doing is draw a scalene acute. Draw a scalene right. Draw a scalene obtuse. Then see if you can do the same with isosceles. Draw isosceles acute, isosceles right, isosceles obtuse. If we have three names for the sides and three names for the angles, then in theory, we should have 9 different types of triangles. Okay, so let me show you a little bit in GeoGebra. So now, go ahead and get yourself to GeoGebra and let's draw a triangle. Okay, let's draw a segment, let's draw another segment, let's draw another segment. Okay, what I would like you guys to do is make sure that you're putting down the measures of all three sides. Here, the value. Those are all three different. Okay, so clearly we have three different lengths, so that's scalene. That's scalene. Now, what's happening with the angles? Measure the angles. Measure all three angles. All right, that one is about 78. That one's about 40. This one is about 61. So those are all three less than 90 degrees. So we have a scalene acute. Take this triangle, draw it here, and write scalene acute. Okay, and you have one of them done. Now, because you're in GeoGebra, you don't have to redraw things. If you want to make a scalene obtuse, see if you can pull this out. Oh, look at that. Now I have an angle that's greater than 90. So I have an obtuse triangle, but I have three sides that are different. So now, real quickly, you've just drawn the second one that maybe you could write down scalene obtuse. Please do take the time in your sketch to write down the measures of the angles and write down the measures of the sides to show, to prove that you in fact have drawn a scalene acute or a scalene obtuse. Your homework started in class right now, but your homework is to finish all 9 of these triangles. Please glue this in. If you have some time, see if you can find some interesting observations, anything interesting that you see in your 9 triangles. All right, ladies and gentlemen, have a good day. Thank you, Mrs. G.